Breaking: NASA reports potential biosignature from Mars sample. Closest evidence yet to life on the red planet. By H. S. Kim. September 26, 2025. In a landmark announcement today, NASA revealed that its Perseverance rover has uncovered a Martian rock sample, dubbed Sapphire Canyon, that contains signs consistent with an ancient biosignature. The finding, made in the Jezero crater region, may represent the most compelling evidence yet that life once existed on the red planet. The discovery. The sample was collected in July 2024 from a site called Chayava Falls, an area believed to have hosted water in Mars's distant past. According to NASA's release, the mudstone contains organic carbon-bearing nodules enriched with minerals, such as Vivianite iron phosphate and greigite iron sulfide. On Earth, these minerals are frequently linked to microbial activity in oxygen-poor, water-rich environments. Scientists also highlighted distinctive microscopic textures, nicknamed the leopard spots and poppy seeds, that resemble patterns produced by microbial communities in terrestrial sediments. NASA Administrator Sean Duffy called the discovery the closest we have ever come to finding evidence of life beyond Earth. Still, the agency stressed caution. These features may also arise from non-biological chemical reactions under conditions of heat, pressure, and water. Definitive proof will require returning the sample to Earth for advanced laboratory analysis. Why this finding matters? For decades, researchers have sought evidence of ancient or extant life on Mars. While past missions found traces of water and organic molecules, identifying a true biosignature, a feature better explained by life than by chemistry, has remained elusive. This rock represents one of the strongest candidates yet. The combination of organic carbon, iron sulfur phosphate minerals, and unusual textures make it a prime target for further study. The Mars sample return Catch-22. Confirming a biosignature lies beyond the capabilities of Perseverance's onboard instruments. That responsibility falls to the ambitious Mars Sample Return (MSR) mission, a joint NASA-ESA project to bring Martian rocks back to Earth. But MSR faces steep hurdles. An independent review in 2023 warned that costs could exceed $10 billion and delay sample return to 2040. Unless the mission design was overhauled, NASA has since been exploring cheaper, faster alternatives. Today's discovery underscores the Catch-22. The strongest evidence yet for Martian life demands the very mission most at risk. The scientific high bar. Why caution is key. The scientific community, by tradition and necessity, demands extraordinary proof for extraordinary claims. Several experts were quick to emphasize restraint. Astrobiologist Karen Rogers explained, "These signatures are intriguing, but they are not definitive. Similar mineral patterns can form without biology. We must be careful not to jump ahead of the evidence." Alternative explanations under consideration include abiotic redox reactions, mineral alteration, driven by ancient groundwater or post-depositional geochemical processes that mimic biological textures. Until the samples are returned and studied in Earth laboratories, no single hypothesis can be confirmed. What's next? 1. Continued rover analysis. Perseverance will keep surveying Jezero crater, searching for additional samples with similar signatures. 2. Sample caching for return. Teams are refining plans for the Mars Ascent Vehicle and Earth Return Orbiter to ensure the most critical samples, like Sapphire Canyon, make it home. 3. Earth-based laboratory work. If returned, scientists will use ultra-sensitive isotopic and molecular techniques to test whether the features are truly biotic. 4. Global scientific review. Peer scrutiny and independent replication will be essential before declaring life confirmed. a historic step closer. Whether ultimately biological or chemical, today's announcement is a milestone in humanity's exploration of Mars. It sharpens the focus of planetary science, adds urgency to the Mars sample return mission, and brings humanity closer than ever before to answering one of its oldest questions: are we alone in the universe?
It's time to study new words in context. 1. Biosignature. Definition: a biosignature is a physical or chemical feature that provides scientific evidence of past or present life. It is often used in astrobiology to identify signs of life on other planets. Example: scientists believe the organic patterns in the Martian rock may be a potential biosignature. 2. Nodules. Definition: nodules are small, rounded lumps or growths that form naturally, often inside rocks, minerals, or biological tissues. Example: the rover found tiny nodules scattered across the rock surface. 3. Vivianite. Definition: vivianite is a blue to green mineral made of iron phosphate, often found in wet, oxygen-poor environments where organic matter is present. Example: the presence of vivianite suggests the rock may have formed in water-rich conditions. 4. Phosphate. Definition: phosphate is a chemical compound that contains phosphorus and oxygen, commonly found in minerals and living organisms. It plays a key role in energy storage and biological processes. Example: phosphate minerals are essential building blocks for life on Earth. 5. Grayzite. Definition: grayzite is a dark, magnetic mineral made of iron sulfide, often formed by microbial activity in environments without oxygen. Example: scientists detected grayzite in the Martian rock, raising questions about its origin. 6. Sulfide. Definition: sulfide is a chemical compound that includes sulfur combined with a metal. It can form naturally through geological or biological processes. Example: sulfide minerals often indicate that chemical reactions occurred in the absence of oxygen. 7. Terrestrial sediments. Definition: terrestrial sediments are layers of soil, sand, or minerals that accumulate on land or in water bodies on Earth. They can preserve traces of environmental conditions and life. Example: the patterns in the Martian rock resemble those found in terrestrial sediments formed by microbes. 8. Extant life. Definition: extant life refers to life that still exists today, as opposed to extinct life, which no longer exists. Example: scientists are not only searching for ancient fossils, but also for signs of extant life on Mars. 9. Elusive. Definition: elusive means difficult to find, catch, or define clearly. Example: evidence of extraterrestrial life has always been fascinating but elusive. 10. Catch-22. Definition: a catch-22 is a situation where the solution to a problem is blocked by the problem itself, creating a no-win scenario. Example: the discovery creates a catch-22. NASA needs the sample return mission to prove life, but the mission is delayed. 11. Restraint. Definition: restraint means holding back emotions, actions, or conclusions, especially when caution is required. Example: scientists showed restraint by not calling the discovery absolute proof of life. 12. Abiotic redox reactions. Definition: abiotic redox reactions are chemical processes involving the transfer of electrons between substances, occurring without the involvement of living organisms. Example: some mineral patterns on Mars could be explained by abiotic redox reactions rather than by life. 13. Mimic. Definition: mimic means to imitate or copy the appearance, behavior, or effect of something else. Example: certain geological processes can mimic the patterns made by microorganisms. 14. Caching. Definition: caching is the act of storing or hiding something safely for later use. In space exploration, it often refers to collecting and securing samples for future study. Example: Perseverance is caching rock samples to be returned to Earth. 15. Isotopic. Definition: isotopic refers to isotopes, which are forms of the same chemical element with different numbers of neutrons. Isotopic analysis can reveal details about a material's origin and history. Example: scientists plan to use isotopic testing to determine whether the carbon in the rock came from biological activity.
Comprehension questions. 1. What rover discovered the sample nicknamed Sapphire Canyon? Answer: NASA's Perseverance rover. 2. In which Martian region was the sample found? Answer: the Jezero crater, specifically at a site called Chayaba Falls. 3. What year was the Sapphire Canyon sample collected? Answer: July 2024. 4. Which two minerals found in the rock are often associated with microbial activity on Earth? Answer: Vibionite iron, phosphate, and grayzite, iron sulfide. 5. What distinctive textures in the rock did scientists nickname? Answer: the leopard spots and the poppy seeds. 6. Why does NASA stress caution in interpreting the discovery? Answer: because non-biological chemical processes could also produce similar mineral and textural features. 7. What is a biosignature as used in the article? Answer: a feature or pattern, better explained by life than by non-biological chemistry. 8. What mission is considered critical for confirming whether the rock's features are truly biological? Answer: the Mars Sample Return MSR mission. 9. What are the major challenges facing the MSR mission? Answer: high projected costs over $10 billion and potential delays, pushing sample return to around 2040. 10. How did the article describe the catch-22 of today's discovery? Answer: the strongest evidence yet for life on Mars requires confirmation through the very mission, MSR, that faces the greatest risk of delays and budget issues. 11. What principle does the scientific community follow when evaluating extraordinary claims, such as life on Mars? Answer: extraordinary claims require extraordinary proof, and alternative non-biological explanations must be ruled out first. 12. Which astrobiologist was quoted in the article urging caution? Answer: Karen Rogers. 13. What are some non-biological explanations scientists are considering for the observed features? Answer: abiotic redox reactions, mineral alteration from ancient groundwater, and post-depositional geochemical processes. 14. List 2 steps scientists plan to take next in the search for life on Mars. Answer: 1. Continue rover analysis to look for similar samples. 2. Cache samples for eventual return to Earth via the MSR mission. 15. How did the article conclude about the significance of the finding? Answer: it called the discovery a milestone that sharpens the focus of planetary science, adds urgency to MSR, and brings humanity closer than ever before to answering the question, are we alone in the universe?